Hello everyone, I am Pavitra Devi, working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science in Dr. SNS College of Arts and Science. I am going to take the class about paging in operating system. Paging is nothing but it is the memory management scheme that eliminates the need of continuous allocation of physical memory. The process of retrieving the process in the form of pages from secondary storage into main memory is known as paging. The purpose of the paging is separate each procedure into the pages. Next one, what is paging in the operating system? Paging is the memory management scheme used to operating system efficiently manage the memory resources. It allows the operating system to divide the logical address space of the process into fixed size of block is called as page. So paging is the fixed size of blocks. So these pages are the mapped to the physical address and enabling the efficient and memory allocation, the retrieval of the process. The paging is the storage mechanism used in the operating system to retrieve the process from secondary storage to main memory as the pages. The primary concept of behind the paging is break each process into individual pages. Thus, primary memory would also separate the frames into the frames. One frame is assigned to the paging. The one page of the process must be saved in the one of the following given frames. The page can be stored in various memory locations, but finding the continuous frame or hold the process always in the main row. The process pages are usually only brought into the main memory, which they are need, else they are stored in the secondary storage devices. The frame size may vary depending on the operating system. Each frame must be the same size, but the page present in the paging are mapped onto the frames. The page size should be similar to the frame size. Why paging is used for memory management? Why we are using in paging in memory management? Paging is the memory management scheme that eliminates need for the continuous allocation of the physical memory. It helps to how process memory divided into stored in the random access memory. The mapping between the logical page and physical page frame is maintained by the frame table, which is used to the main memory management unit to translate the logical address into physical address. The page table maps each logical page number to physical page frame number. By using the page table, operating system keep track of the mapping between the logical address used by the program and physical address actual location of the memory. Next one, paging is the memory management technique that addresses common the challenges to allocating and managing memory efficiently. Here we can understand why paging is needed as memory management techniques. First one is memory is not available in the single block. The program often more memory than what is available in the single continuous block. Page break memory into the smaller and fixed size pieces and making it easy to allocate the scattered free spaces. Next one, process size can increase or decrease. The programs do not need to occupy continuous memory, so they can grow dynamically without the need to be moved. Next one, types of paging. There are a lot of types of paging. That first one is simple or single level paging. Each process has been in the single page table. It is called as simple paging. Next one, multiple paging. Multiple paging is each map is virtual number to physical number suitable in the small address space. The limitation for the address space, the page table become too large. Page table themselves or page reduce the memory used for the page table. Common level 2 and level 3 or even more 64-bit system. For example, logical address point to page directory point to page table point to frame. Next one, advantages of the multi-level paging. It is reduce the memory overhead for the page table. Inverted paging. Inverted paging is nothing but uses of one page table for the entire system, not for the process. Page table entries are indexed by the physical frame number, not virtual page number. Each entry includes process ID plus process or a page number. The advantage is save memory when the process or running state. Next one, hash paging. Uses 64-bit architecture in very large address Dematch paging. Dematch paging is nothing but pages are loaded into the memory only when they are required on the demand paging. Advantages: save the memory or allow for the larger process segmented in the paging. Next one, demand paging. Pages are loaded into memory only when required on demand of the paging. That is called as demand paging. Pages are not memory cause a page fault or loaded from the disk. Advantages of the demand paging: the save memory and allow a large process. It is the advantages of demand paging. Next one, segmented paging. It is called as hybrid paging. Combine segmentation and paging. The combination of both segmentation and paging is called as segmented paging. It is the hybrid paging. Memory is divided into segments. Each segment further divided into pages. It is the segmented paging. Next one, efficient memory utilization. Since paging can be placed in the non-contiguous memory location, even small space can be utilized, leading to better memory allocation. Next one, support virtual memory. Paging enables the implementation of virtual memory, allowing the process to use more memory than physical available by swapping pages between RAM and secondary storage. Next one, ease of swapping. Individual pages can be moved between the physical memory and disk swap space without affecting the entire process, making swapping faster and more efficient. Next one, improved security and isolation. Each process works within its own set of pages, preventing one process from accessing another memory spaces. These are the advantages of the paging. Next one, disadvantages of paging. It is opposite for the internal fragmentation. It is the size of the process is not perfect multiple pages of size. It is unused page in the last page resulted in internal fragmentation. Next one, increased overhead. Maintain the page table require the additional memory and processing. For large process, the page table can grow significantly, consuming the valuable of memory resources. Next one, page table lookup time. Accessing memory requirement, translating logical address to physical addressing using page table. The additional step increase the memory access time, although transaction look over the buffers and help to reduce the impact. Next one, input output overhead during the page fault. When a required page is not the physical memory, that is called as page fault. It need to be fetched from the secondary storage, causing the delays and increased the I/O operations. Next one, complexity in implementation. Paging is required sophisticated the hardware and software support, including the memory management unit, that is MMU, and algorithms for the page replacement, which add the complexity to the system.